Hello students and welcome to the automobile engine class. Myself Shankho Ghosh, assistant professor of automobile engineering department at Dr. Sudhir Chandrasur Degree Engineering College under the JIS group. So students, from the last classes we are studying we have started the discussion about the third module. The third module basically covered and third module basically covered the engine cooling system. In the engine cooling system, in the last class we are discussing about its introduction section, its requirement, and or and why it is why needed some efficient types of cooling system. And now the second part of this cooling system, we are continue this topic with the heat transfer and the various types of cooling system. So students, let's start the today's class as a second part of the engine cooling system. Now today we'll continue this class with the heat transfer section. The heat transfer is a discipline of the thermal engineering that concerns the generation, uses, and conversion and exchange of the thermal energy. Heat transfer is a discipline. Basically, heat transfer is a discipline of the thermal engineering where it basically concerns the generation, uses, conversion, and the exchange of the thermal energy in between the physical system. The heat treatment is basically classified according to the various mechanisms such as thermal conductivity, thermal conduction, thermal convection, and the thermal radiation. These are the main three things. So in this way we can classify the heat transfer. Here we the engineers are consider the transfer of mass of different chemical species, either cold or hot, and to achieve a heat transfer. While this mechanism have them distinct characteristics, and they often occur simultaneously in the same system. Here, let's start with this conduction portion. Conduction is the transfer of heat. Conduction is the transfer of heat from one part of a substance to another part of the same substance, or one substance to another in physical contact with it without appreciable the displacement of molecules forming the substances. So this is basically heat conduction is the directly microscopic exchange of kinetic energy of the particles through the boundary between the two systems. When an object is at a different temperature from the others, other body or the its surrounding. The heat flow so that the body basically heat flows so that the body and the surroundings reach the same temperature at which point they are in thermal equilibrium. So such a spontaneous heat transfer always occurs from a region of high temperature to another region of the low temperature as prescribed in the second law of thermodynamics. And when we are talking about the convection is the transfer of heat. The convection is the transfer of heat within a fluid by mixing of one portion of the fluid with the another portion. So convection is the transfer of heat within a fluid by mixing of one portion of the fluid with the another. So this heat of convection basically occurs when the bulk flow of fluid, that may be gas or may be a liquid, which carry the heat along with the flow of the matter in the fluid. And the flow of fluid which may be forced by the external processes or sometimes by bouncy forces which is caused when the internal energy expands in the fluid. So thus the influencing its the own transfer. The latter process is called the natural convection. So all the convection process also move the heat partly by the diffusion as well. So another form of convection is the forced convection. In this case, the fluid is forced to flow the use of a pump, fan or other mechanical means. So here this convection can be classified in the two ways. One is fuel or the natural convection and another one is the forced convection. When we are talking about the natural convection, basically means it occurs, the fluid circulates by virtue of the natural differences in densities of hot and the cold fluid. The denser portions of the fluid moves downward because of the greater force of gravity. As compared with the force on the less dense. And when we are talking about when we are talking about the forced convection, that time the work is done. That time of forced convection, the work is specially done to blow or pumping the fluid. So that's why it is called, or it is said, to be a forced convection. So beside these two types of heat transfer, conduction, convection, and there are the another types of heat transferring methods are also available, which is called the radiation. The radiation is the transfer of heat which is done to transfer of heat through the space or any matter by means of the other than the conduction and or the convection. So this phenomenon is not the very significant with regard to the reciprocating of the IC engine. So here are three types of heat transfer mathematical process are there, where in the last case when the radiation method basically occurs through a vacuum or any transparent medium, that may be solid or when you go into fluid or any gases. It is the transfer of energy by means of photons by means of photons in the electromagnetic wave, which is governed by the Sen's law. So if we are talking about the IC engine, the in IC engine heat can be transferred in the three of them. Here also has the conduction methods, the convection methods, and the also radiation methods. So as you can see in this picture, you can see in this picture, this one is the heater core from where the air is flowing. This one is the air flow inside this one is called radiator. Here is the fan. This one is the so student, here is the radiator, this one is the fan, here is the water pump, here is the thermostat housing, there is the pipe flow, this one is the lower radiator hose, this one is the upper radiator hose which is connected from the engine. Here is the in this zone the coolant from the engine is entered in this sides and in this side. So here the thermostatic valve, the heater feed hose which is passes through this heater core, and there is an fan is connected here. This is the air flow and the thermostat also placed in here. So here this one is the coolant expansion stroke. So here when the engine heat is passing through this here, so at first of all it is blown with the liquids. This passes here with the liquid section with the liquid that is on the water flow. So these types of heat transfer methods are basically called as the they are called as the convection type methods. Then here is this connected with the metal, and here is the airflow. So this one is the conduction type and convection type. And when if we talking about the four, two-wheeler, and there some air cooling systems are also there. This is the type. This is a type of the radiation method. So here in this way the heat can be transferred. Now coming to the classification of the cooling system. So students, basically the cooling systems can be classified in the two way. One is air cooling system, another is water cooling system. Students, let's start here with the cooling system. The cooling system, the heat which is conducted to the outer part of the engine. In this types of cooling system, the heat which is conducted to the outer parts of the engine and which is radiated and conducted away by the stream of air which is obtained from the atmosphere. In order to have the efficient cooling by means of air which providing the fins around the cylinder and the cylinder head, which increase the contact area. So basically during the air cooling system, the heat which is conducted to the outer part of the engine it is conducted to the outer part of the engine is radiated and conducted away by the stream of air. So basically in the air cooling system, the air cooling system, conduction heat transfer methods and the radiation of heat transfer methods has been applied. So in this way the heat has been released from the engine. So in order to have the efficient cooling system, by means of air which providing the fins and around and these fins are basically constructed or placed around the cylinder and the cylinder head. As it is placed around the cylinder and the cylinder head, so obviously the contact area of the fin has been increased. As the contact area of the fins is increased, so the heat releasing methods through the heat conduction transfer methods, it can be released very easy, very quick, released very quickly, and after that then it is coming to the conducted then after that it is connected with the air. So that's why it is also transfer the heat with the help of the radiation too. So according to the combination of the radiation and the conduction, the air cooling system are so much effective. Here the fins are basically designed as a metallic ridge which are formed during the casting of the cylinder and the cylinder head. The fin which are metallic ridge which are formed during the casting, which are formed during the which are formed during the casting of the cylinder and the cylinder head. The amount of heat which is carried out, the amount of heat, sorry, the amount of heat which is carried out or carried off by the air cooling depending upon the few factor. First of all is the total area of the fin surface. The total area of the fin surface. Which one is the factor number 1. Now next is the factor number 2, that is the velocity and the amount. The velocity and the amount of cooling air. Now next, that the factor number 3, that is the temperature of the fin and the temperature of the cooling air. So basically, according to the based on these things, the heat is carried off. The heat has been carried off from this air cooling system. So students, here in the part 2 of this cooling system, we discuss about the heat transfer methodology, various heat transfer methodology, discuss here the heat transfer methodology and the various types of cooling system. So on the next class we discuss this air cooling system very elaborately. So still then, stay at home and stay safe. Thank you so much students.